Ready? Here we go. Definition. I'm going to put them side by side. Okay, so you have regular polys and irregular polys. Regular polygon, the one that you're most familiar with probably is a square or an equilateral triangle. And we know that all sides are congruent. And the symbol for that is, it's going to bleed a little bit into the other column, but that's fine. That's the symbol for things being congruent. It's an equal sign with a squiggly line on top, and all angles are congruent as well. Okay, so that's actually always interesting how that works. Okay. Irregular, if you can cut it, sorry. Irregular, you can only say that some sides may be congruent. I'm going to zoom in there. Some sides may be congruent. Some angles may be congruent, but when you see the word regular, you're guaranteed these two things are being met. Okay, which is very interesting, because that if all angles are the same, then you know that whatever the total should be, you can split it evenly amongst however many angles there are. So examples would be equilateral, right? Equilateral triangle. What do all angles add up to in a triangle? 180. Dividing that by 3, right? If you go 180 divided by 3, each angle is worth 60. If you ever see a triangle where all angles are the same, you're guaranteed that all sides will also be the same, right? So that's kind of a neat property. However, it doesn't work with a 4-sided shape. For example, a rectangle, all 4 angles are 90, right? But not all sides are the same, right? So just keep that in mind. So I'll put this there, and I will say that an isosceles triangle right? It would have these two sides as being the same, but this side would be different. So that's how the markings would go. And I think I just need to make sure you understand this. It's the angles across those sides that are going to be the same. Therefore, that third angle will be different. Right? Okay. So I continue my line here, cutting them. Right. On this side, you have a square. That would be a regular 4-sided shape. So boom, boom. You have a 90 in every corner. Right? You could go 360 divided by 4 sides, and you get the 90 on each corner. And on the other side here would be a rectangle. So you still have all sides being all angles being 90, but this side is the same as that, whereas this side I'll maybe add, this is what I want you to do if you go back up here. This triangle here has two check marks. All sides are equal, all angles are equal, right? This one here, are all sides equal? Nope. Are all angles equal? Nope. So this one would fail both tests, right? Both of these would fail, right? For the square, both pass, of course. For the rectangle, the sides, all sides being the same, fails, but are all angles the same? Yes, it would still be considered an irregular polygon. Polygon stands for many sides, right? So let me just go up here. Poly is many, right? Gon is angles. Many angles, hence many sides, right? Like it goes both ways. So this is just an aside. So a triangle, a square, rectangle, those are all polygons. But we're right now distinguishing between regular and irregular. If you see the word regular, it means a lot to us. It means that these two are true. It's just like saying parallel. It means more than just a word, right? Let's keep going. Polygon, a closed shape, with the same number of sides and angles. So if it has 3 angles, it will have 3 sides. If it has 4 angles, 4 sides, 5 angles, and so forth, right? No surprises there, I'm sure. And then you have convex versus concave. And we will deal with convex like for the majority. Just make a beehive, right? Like the hexagon. Don't make it perfect, right? Like just that'd be convex. There's no reflex angle. Anybody know what a reflex angle is again? It was in our notes. Bigger than 180, right? Reflex is bigger than 180. So a concave is like this, watch. Just try to do this, go into the shape, then go back out of the shape. And so if we look at inside this shape and you focus on this corner here, this is bigger than 180, right? There's a reflex angle. It caves in, kind of thing. All polygons have interior and exterior angles that are supplementary. Sum of 180, right? That's what supplementary means. And I want to highlight that because it's going to come up a lot. Interior and exterior angles are supplementary. You don't know how important angles are until if you ever do a renovation in your house, anything like that, if you make stairs, angles everywhere. So if you don't know how to work with angles and you're like, what? That's when you learn, okay? All right, next page for me. I don't know about you, but here it is. This is the easiest way to do it. Draw a triangle, please. Just draw a triangle. Try to make it look equilateral. Okay. And this is how you identify how many interior angles will this particular triangle have. Well, it's 1, 2, and 3. These are called interior angle. They're inside the shape. And so it has 3 interior angles, therefore it will have 3 exterior angles. So you go to any corner and just extend one of the sides. So for example, I will travel along the bottom, and as soon as I hit the corner, I will go dash. I'll make a dashed line out like this. And this angle right here that is formed between the side of the triangle and that extension, that is called the exterior angle. Okay, and this is called the interior. It's gonna be, I hope you can see that. It's interior angle and exterior angle right next to each other. Can you see that they add up to 180? Can you see that? I hope you do. So interior angle plus the exterior angle always add up to 180. This is going to come in very handy because if you know one of them, to subtract it from 180 and you got the other. Okay, I'm going to use that extensively. And let's go over to the top here. So if you travel along this side, so as soon as you hit the corner, you keep extending that side, keep traveling, right? Like you got to go straight. It's got to be a straight line if possible. And there you have your exterior angle. So I will just call it E there. Then I travel down here. When I hit the corner, I go dashed line, and it's as if you go straight, right? You extend that line, and there's your exterior angle. And we call the interior angle just capital I, sorry. Okay. So 3 sides, 3 exterior angles, 3 interior angles. Okay, 3 sides, 3 I's, 3 E's. If that makes any sense, right? And another fact is that sum of exterior angles is always 360 degrees. This is a very important property. Okay, regardless of the number of sides. And regardless, I'm just using that, if regular or irregular. This is always true. Think about it. Equilateral triangle. If every interior angle is 60, what is every exterior angle? 120, right? 3 times 120? 360. That's just one example, right? Think of a square. If the interior is 90, then the outside is 90, right? 90 times 4, 360. It's always 360. Let's do some formulas here. So write down the formulas and make sure you write them down correctly. I write them as a function, and I'll tell you what they mean in a bit. This is the sum of interior angles. If you use this formula, and where n is the number of sides, n is the number of sides of that shape, right? That's very important. So let's try a triangle. N would be 3. 3 minus 2 is 1. 1 times 180 is 180, right? So it works with anyone. Okay, so I of n, this one is a bit, it starts exactly the same as before. N minus 2 times 180, but you're going to divide that by the number of sides. Okay? And this calculates the measure of each interior angle. Next is Cn. It's a very easy one. 360 divided by n. And that's the measure of each central angle. And this one, the last one, it's exactly the same as the central angle. And I will explain that down the road. The measure of each exterior angle. And I need to add, I'm going to go off to the side a little bit here and just make sure that ice, you see that? Ice, right? It only works with regular. Only works with regular polys. Sorry, it's off to the side, right? So those three formulas, the sum works for all, but these three only work for regular polygons. So you cannot use those because it's always dividing it by the number of sides, assuming that all sides are equal, right? Make sure you do that, right? These only work with regular. Ice only works with regular. All right. Label ice. Those are the only ones you can label on a diagram. So what we're going to try is a pentagon. Let's see if we can do that. So let's say I gave you this shape and I asked you to label the interior, the central, and the exterior. And this is how I do it. I pick any corner inside the shape, just like a triangle, just identify it, and so that angle right there is called the interior. I'm just going to label one. How many are there? in this case 5, right? Let's make a note that n is equal to, let's count. I always make a mark on it because once you have 20 or more, which you will have, you will double count. So 1, 2, 3, 4, 5 sides. Okay, 5 sides. Let's make that clear that this one will have 5 sides. To get the central angle, central, center, think of center, go to the middle, make a dot, and then just make a pizza slice. So you go to one corner, go back to the center, go to the one that's right next to it, right? And that angle formed between those two cuts is called the central, this angle right here. If you think about it, around the center, if you were to go all the way around, that's 360 degrees, right? So if you just want one slice, which is along one of the sides, you go 360 divided by the number of sides. And the exterior angle, I will do it right next to my interior angle. I will travel along the base here and then just extend it like this. And this is called the exterior angle. Now you've labeled the interior, the exterior, and the central. There are 5 central, there are 5 interior, there are 5 exterior angles. I just labeled one of them. Okay, let's do a little bit of math here. If I asked you to calculate the sum of all angles of a 5-sided shape, so you put n into there, that would be 5 minus 2, I'm using the formula I gave you up there, times 180 degrees. And that is 3 times 180, right? Which is 540 degrees. So the sum of all the interior angles for a pentagon, we'll talk about names later, it would be 540. The measure of just one interior angle, which we labeled I, of a 5-sided shape, assuming it's regular, would be 5 minus 2, exactly as before, except for you're going to divide it by n, which is 5. So I'm going to borrow from before, from my answer up here, because I know already the top is 540. It's the sum of all angles. I'm going to split that evenly among 5. And that is 108 degrees. So each one of those eyes, right, would be 108 degrees. Central angle, this one is easy. That's 360 divided by 5. And so that would be 72 degrees. The exterior angle, and this is interesting, right? Like, why is the exterior angle exactly the same? For now, you just have to trust me. But the central and the exterior are always going to be the same if it's a regular polygon. I'll put the note here, assume regular pentagon. I'm assuming you all have heard of pentagon before and you know what a pentagon is, so we'll do names next class, okay? I think we're going to leave it here. I will say no homework, which means